So we're not talking about mapping Wi-Fi networks and triggering interesting traffic patterns. Please give a very warm round of applause to Kayla.
Thank you. Yeah, here we are at the end of the day. Thanks for staying. My name is Kayla Madrigal, or Madrigal as it would be in Spanish. I'm from the US. I've been doing mostly software engineering for a while now. I can't remember, maybe 18 years. But I've gotten into the security space in the last several years. I think it's just a lot of interesting stuff, a lot of fun stuff. Right now I'm working at Mandiant, which is a subsidiary of FireEye. And basically, Mandiant, they're the incident responders, and so they're kind of like the ninjas, you might say. I'm not really one of the ninjas. I'm more of like the sword maker on the team. So I'm an applied researcher and help build the tools for our people. So we're talking mostly about Wi-Fi today. But I think the whole wireless hacking space is really interesting. I was like into the whole IoT stuff before I knew it was IoT. Back a few years ago, I built a little Raspberry Pi home security system, and then I started playing around with like software-defined radio, and it's fun to get down to that level. And one of the things I think it's kind of interesting about wireless hacking in general is, well, there's a couple things. One is you can control things in the physical world, so you're kind of like writing these incantations into a computer, which is modulating the electromagnetic fields and actually making things happen in the physical world, which is kind of magical. The other cool thing that's kind of interesting about it to me is that typically, if you have a vulnerability in an app, it'll get patched probably pretty soon, and it'll be no more. But a lot of times in wireless hacking kinds of stuff, it's a systemic problem, and so it sticks around, sometimes almost indefinitely. So I think it's kind of an interesting area. But yeah, so the software-defined radio stuff is down here at the physical layer, and then TCP/IP. Maybe you're doing promiscuous mode or something like that is up here. Today, though, we're talking about if this is the OSI model, layer 2. So 802.11. Let me make this slightly bigger. And it's an area that I kind of ignored for a while because back in the day it was like, especially before encryption, the TCP/IP stuff was kind of cool. A little less so now because of the encryption. Like I said, layer 1 is pretty cool because it's kind of the Wild West, because just recently we've been getting like good tools for software-defined radio for a cheap price. So that's fun. But layer 2, it's always been like, because it's all encrypted, right? So at 802.11, almost everything's encrypted. So really, what can you get? The data you have in there is, you've got a few fields that have to be unencrypted for the protocol to work. You have your source MAC address, destination MAC address. In some of the data frames, you can pull out the SSID. You can get things like the frame type, and then most of the data is encrypted. But if you're kind of keeping track of stuff and you're inferring data from what you're pulling in, you can actually additionally get other fields like the power level. Your wireless card will pull that out. So it's not actually in the data frame, but it's something you can pick up. Time, obviously, you can imply. Other things like the manufacturer of the device, the IEEE puts out basically a database with the organizationally unique identifiers. So you can, from a MAC address, identify who the maker is. And of course, the SSID, which again, it's not always present, but if you see a given frame, if you're keeping track of what that's connected to, you can infer that information. So this whole like talk and project came from a stupid problem that I had. One of those things where, you know, I totally overkilled solving a problem that wasn't very meaningful. But basically, so I had an IP camera and a home security system, and they didn't talk to each other. But I wanted, if the camera detects motion and the system is armed, just sound the alarms. So how do you do that? I was thinking, well, I could try to route the camera or something like that. The security system had a nice API, so it was easy to script calling that. If only I could figure out when is the camera detecting motion. So the simplest solution I could think of was just look at the MAC address of the camera and look for how much data it's sending, because even though you can't see the data because it's encrypted, you can see the quantity of data, right? So you can just say, you know, basically look at it and determine, okay, if it's more than maybe half a meg in 30 seconds, consider it motion detected, because it's going to upload the video as quick as possible to the cloud. You know, if someone breaks in, they want to get the video off as soon as possible. So that was kind of the problem. And as a Pythonista, for me, the only prescription was more Python. And so the solution was this little Python program called TrackerJacker that I wrote. And so it's open source. It's on GitHub already. It's starting to get a little bit of contributions from the community, which is cool. It's on PyPy, so you can just pip install it. It's Python 3 only. It's mostly working on. It's mostly been developed on Linux, but it has very rudimentary OS X support. So anyway, to a demo. So the first demo I've got to do is just the little, and you can turn the video or audio on for this. This was kind of just my proof of concept on the solution. So I just had TrackerJacker running on a laptop here, and then I had, this was the siren for the security system down here. And over here, you can't hardly see it, is the little security camera. So you'll see, I'm going to move into the view of the security camera, and you should see the siren go off. You should see TrackerJacker hit over here, and then the siren go off. This is the only recorded demo. The rest are live and with audience participation. So I don't know if sound is going to be here. Ah, there we go. So you should see the siren go off and start making.
See when it prints out on the screen.
All right, that's it. So it solved my little problem, and that was fun. All right, so this idea of, you know, looking at a device and looking at its traffic pattern, you know, that was kind of the basic problem. But so I thought, well, this is it's kind of cool, you know, because one thing I noticed was, well, you know, I'm at layer 2 here, so I don't even have to be connected to my Wi-Fi to see this, to see my camera detect motion. And so I can see, you know, I could see based on the MAC address who the maker is. You know, so if it's a drop cam or a Nest cam or something like that, you could see it's a camera. And theoretically, a neighbor of mine could be looking at this and seeing, oh, I see there is motion in the house just now, or I haven't seen any motion in the house for a while. So, you know, it was kind of like, suddenly the problem, or the solution to the problem became a little more interesting, because I was like, well, what other kinds of things can you, what other kinds of signals can you pull out of the encrypted 802.11 layer, right? And you know, I realized, well, you could do things like tracking people, for example. So this is live. This is actually a little plugin I wrote just for DeepSec. So it's looking for DeepSec attendees by their MAC address. So I've just been around the conference listening in for nearby packets. And, this is kind of, there's going to be some false positives in here. But basically, it's very easy to gather MAC addresses, just put them in a file. And so this is just saying for every incoming data frame that I see, if it's in this little list, just do an alert. And so it'll do stuff like, the vendor, the power level, so we can see how close people are, and then, the SSID they're connected to if they're connected to one. And it's kind of a good demo. Like, this could, it could definitely up the creepiness level a little bit. Like if I went around town and I was like, I'm going to find a DeepSec attendee, not at DeepSec, and but I haven't. I'm too lazy. Anyway, it's just kind of a good example of how trivial it can be to track people. Using this kinds of technology, just very simple Wi-Fi adapters, you could very easily build a privatized tracking network if you wanted. I believe in the Edward Snowden revelations, I think he said they were using this very technique to track people. Just to show you though what that plugin looks like. So I should back up a minute. So all right, so we have the solution to this problem of I have some traffic pattern, any kind of traffic pattern that I might want to look at from a 802.11 perspective. Basically, Tracker Jacker lets you do that very easily. So you can actually, without, I won't show this right now just for time's sake, but you can just say, I just want to track this MAC address, and just single line, and I want to print out something. Or there's a switch to just say, call this script. So anytime this MAC address hits, call this script. Or you can specify, if I see 300 bytes or more in a 5-minute window, then call this script or whatever. The most useful part of it, though, at least for myself, is this little plugin system. So you can have it just call a script or call a plugin. That's kind of the action that can be taken when there's a match. And so the plugin, so I have this little plugin system that it's very basic Python. So there's no inheritance or anything like that. Basically, all you do is you write a Python class that has a call function. And let me make sure it's big enough. And in the call function, you can just take these different parameters that are supported. So device ID is going to be the MAC address or the SSID or the BSSID. Yeah, that's right. If it's a frame and it's got one device, maybe it's from a client, it may also have a BSSID and an SSID. It also gives you things like, here's the power level, here's the vendor. So, this plugin here, for example, let me run this one. So this is like about the simplest plugin you could write, and it just counts Apple devices. So each time there's a new Apple device it's never seen, it just prints out a line. And so you can see this happening live right here. Some are pretty close, negative 54 dBm, whatever. But this is like 12 lines of code, including space, new lines and that kind of stuff. So you just basically pass in the parameters you want and do whatever you want with them. I'll show a couple more plugins, I think, in a minute, if time permits. So this kind of responding to traffic patterns and all that, that's kind of one of the primary use cases of Tracker Jacker. The other one is it has this other mode called map function or map mode. And so what that looks like is like this. And so what this does is, so this, it's basically Nmap for Wi-Fi, or for Wi-Fi networks. So if you've ever wondered, well, what are all the Wi-Fi devices around me? So you want to see every single access point, so every single SSID, and under that you want to know every single node, every single BSSID, and then you want to list under each node in a network, let's see all the clients who are connected to that node. And that's exactly what Tracker Jacker does. And so what it does is it's just kind of displaying, as it finds new stuff. But by default, it saves everything out to this YAML file. So it's just called Wi-Fi map.yaml, and very simple format. So of course it's YAML, so it's human readable, but it's also very easily parsable by a program. So it's kind of this little file is both the user interface and the database and the part of the interoperability. So the way this works is everything here at the top level is an SSID. And then under each SSID, you have some list of BSSIDs, which is the different, basically MAC addresses of each node in the network. And then under that, you have maybe what channel it's running on, and then you have the list of devices that are connected to that node. And so you can see if it's got the vendor, it'll show you the vendor, the signal strength, last time it was seen, all this kind of stuff. And so you can, let's look for a DeepSec one, DeepSec. So you can see DeepSec here. We can see various devices on this network. And it's just an exhaustive list. So if you really want to scan in your area and you're just curious what all's out there, this is a really good tool for that. There's some other tools that do similar stuff, right? You can use AirCrack, but typically it just shows the closest ones, and it's cycling through, but it's not an exhaustive list. And so that's why I find this useful. It could, there could be very legitimate use cases, like maybe you're at an Airbnb and you would like to look for drop cams, maybe. Maybe if you find one, you want to shut it down. So that's kind of the two modes, right? Map functionality and then this tracking/monitoring functionality. Real quickly, though, I want to just go to a little bit of the theory, just very, very quickly, how Wi-Fi works. Mostly from a radio perspective, just to clarify something that was a little confusing to me initially. So the thing is, radio or Wi-Fi is just radio ultimately. And I was doing the SDR stuff, and so I kind of came back to it. And I'm like, oh yeah, it's just radio waves. This is cool. And basically the channels, they just correspond to frequencies. There's 2.4 gigahertz and 5 gigahertz. It's modulated radio waves, though. In theory, you could build a separate ham radio device to intercept this or anything. But obviously, we have cheap Wi-Fi cards, so we use those. One little difference, though. Okay, so how many of you have heard of like promiscuous mode for like a Wi-Fi adapter? Could you raise your hand? Okay, so probably most people. And how many have heard of monitor mode? Okay. So I just want to show the difference between those two. So promiscuous mode is basically you're on a network, and you just say, typically your Wi-Fi adapter will just discard packets that are not meant for its MAC address. Promiscuous mode just says, give me everything on my network, whether it's for me or not. Monitor mode, though, so this only works. Promiscuous mode is only within a network. Monitor mode, however, just says it drops down a layer, and so it says just raw radio. We're just going to be deconvoluting the raw radio waves that are coming in. We don't care about what network it's on or any of that kind of stuff. And one little caveat of that is, there's maybe if you're on 2.4 gigahertz, you have maybe 12 channels. Well, you can't listen to all those simultaneously because we're constrained by what the radio can receive. So you have channel hopping. You've got to be if you're in monitor mode, you don't have a manager that's setting this channel and all that kind of stuff. So it's up to you, if you're going to do this kind of stuff, to rotate through the different channels if you really want to exhaustively list everything that's out there. That's, of course, Tracker Jacker handles that automatically, so it makes that nice and easy. Let's see. So that's kind of the value add that it's doing the channel rotation. If you want it to do a probabilistic channel hopping, where it's like if you're looking for a particular device, it'll like heavily weight the channels that it sees that on. But the default is just round robin. So the other stuff, though, is, again, the plugin system. It's actually keeping this internal database for you of, okay, I know that this MAC address, even though it doesn't say in this data frame, it's on the DeepSec network. From previous frames, I've kept track, and I know it's on that network. So it makes it easy where if you want to write a nice plugin and you say, I just want to see everything on this network, or whatever, you can do that. So let's see, another simple plugin demo. This one's not terribly useful. This is actually kind of similar to what you get with AirCrack, right? But it's just kind of an example of the flexibility. Just list the top nearest devices. Let's see. This is a fun one here. Let's try this. So how many of you? Well, no, it didn't paste right. How many of you have ever done a DAuth attack, like 802.11? All right, so you know how you have to figure out what SSID it's on and what BSSID, what node and network it's connected to, and all that kind of stuff, right? That's not very useful, especially if you have a multi-node network and it's hopping around as soon as it gets disconnected. Let's see if this finds anything. So this is a very simple plugin. This actually calls out to AirCrack, but it just, if I had a lot of hatred for some particular manufacturer or something like that, maybe it's a drop cam device. And, maybe it's, maybe you're in a Airbnb and you want to kill every, anytime you see a security camera. So this would do that. And so this is just a plugin again, right? So. And just to clear, let me go ahead and stop that so I don't get in trouble. So this plugin, it's like 50 lines of code. And, it's very simple. You basically just say, it has an optional parameter, vendors to DAuth. And so it's cool. It's kind of cool. It's doing all this stuff for you to say, okay, I just saw a data frame. What's the vendor? It looks that up for you, passes it to you. But you could also do other things, right? You could say, I want to be a nice person, and I only care if you're really close to me. So you could also, if you wanted to modify this and say, if it's within negative 50 dBm, if it's like someone near my house, right? You could do something. Maybe you could do a drone killer, for example, right? If you see DJI within some range, maybe you deauth it, or do something else. That's, and I already showed this one. But just to clarify as well, though, so Tracker Jacker it's exclusively passive monitoring. So if you want to call out and do anything active, just use another program for that you can call it with. Of course, if you would like to add first-class active attack functionality to Tracker Jacker, you'd be welcome to. Pull requests are always accepted if they're good. But I'm actually not very picky. I have this little, if you're interested in writing a plugin, I have this little, it's under the main source code under plugin examples. I just have this plugin template. And so you don't even have to be guessing and have this whole boilerplate code. You could just copy and paste the plugin template, and you can see all the fields that are supported, and you can just use any that you want. Just to show you what that looks like, so I'm going to run the plugin demo. template. And so this is showing kind of all. It's very noisy. You're getting all these different fields. You can actually get the raw data frame if you really want to drop down and do something. Another thing is Tracker Jacker is built on Scapy. And so Scapy is a really sweet project. Who's heard of Scapy out of curiosity? OK. So Scapy is really awesome. This is built on Scapy. But if you want to drop down to raw Scapy, you can do that with that parameter. All right. And so a couple practical notes in terms of running this. And this applies to both Tracker Jacker as well as other 802.11 stuff you might want to do. So I think it works best to run it on Linux or in a Linux VM, and to use an external wireless adapter. And I've tested a few, several, quite a few. These are some that I like. This Panda brand, the PAU07 and 09. These are actually pretty sweet. I've not heard hardly anyone talk about them, but they're actually dual band. They work with Linux just out of the box. They support injection mode and all that. So it's really, and they're really nice. So I like those, and the alphas can be really good too. That's what the Pandas look like. And it's nice. It's just a little covert USB device. All right, so in conclusion, the key takeaways would be, at the physical layer, Wi-Fi is just radio waves. So we're constrained by the laws of physics. You can't hide those perturbations in the fields. So that's always going to be accessible to some extent. Theoretically, they could maybe try to improve the protocol to encrypt more of the data, but I don't see that happening anytime soon. It's, as I showed, very trivial to monitor Wi-Fi devices in monitor mode. And I was kind of surprised by the information that was leaked, quote unquote leaked through the encrypted data frames. A little side note, so the security camera I was looking at actually, that I have at home, I got my little thing working, and I was occasionally going in front of the camera and watching it do an alert. And then I disarmed it, and it kept going off. It kept detecting motion even when it was in disarmed mode. So that was kind of weird. And apparently that was one of those things where it was actually recording even when it was in home mode, which was a little bit felt a little naughty to me. Now, they did have a setting. It was the Canary camera. They had a setting where you could turn that off, but it was kind of buried deep. And, that's the kind of thing, right? It's kind of... You may want to monitor your monitor tools. You may want to test, because how would you know? They don't show you in the app when it sees that kind of stuff. And of course, there's this newish tool, Tracker Jacker. Feel free to write any plugins, especially if you're wanting to get into open source contributions or something like that. It's a very simple kind of script to write, and I would probably accept it. And how to not be tracked, it's actually pretty difficult. You can turn off Wi-Fi like on your smartphone when you're traveling if you really care. That would be an idea. But there's not really a great solution if you're using Wi-Fi. If you're home, your smartphone is going to connect to your home Wi-Fi, and or if you're at some coffee shop or whatever. And it's good to be aware. It's good to be aware of that. I'm sure these tools are used by a lot of governments and that kind of thing already. So it's good to be aware of that. So thank you. And I don't know if we have any time for questions. Do we? So yes. So thank you. And any questions?
Thank you. Thank you, Kayla. John, yeah. You again.
Actually, two questions. Is there already a PCAP plugin? You probably would code that as a plugin to log PCAP.
No, but the frame field that it gives you is basically
Yeah,
a PCAP.
okay, I see.
So you could just
And more like future suggestion for implementation, 802.15.4, it's ZigBee or 6LoWPAN on top of it would be very cool. I think it's hard to get hardware for that.
Yeah.
Because the old RZ USB stick is no longer produced, as far as I know. So, but that would be very interesting, I guess, for future things.
Yeah, it would. I've
with
run into that one
framework.
in the wild too.
Yeah.
Yeah.
Yeah, and just another suggestion, when walking around with a laptop, at least it's possible to change your MAC address.
Right. I forgot to mention that. That's a good one too. Yep.
Yep.
Thanks for bringing up this topic. There is a lot to investigate also. On the probe frames, if you want to. The probe frames will reveal where you have been before.
Yeah.
But
yeah.
I was thinking more about your setup, and I was thinking of, what if I want to jam your alarm system and just make you not sleep at night by simply, injecting traffic and making your tool detect that there was some video, but there was no video.
Yeah. That's a great point. That would be possible. So it's all about what's your attack vector you're trying to guard, right? But yes, absolutely. That would be a fun way to hack it.
And regarding applications of whom to monitor, I didn't do it, but what about monitoring your boss coming to the office?
Yeah, so I work from home, and one of the first things I did was look for my wife returning. So when my boss gets home, kind of thing. Exactly. Yeah.
Further questions?
One other side note: there really is a lot of interesting stuff you could do with this. I mean, there's a lot of stuff on my to-do list I just haven't got to. But you could do things like, you have like a theoretical like Wi-Fi fence kind of thing, right? So if you see a device you've never seen in some power level, you can alert. That's another simple thing you can do. You could use several nodes of this to track physical location. Do some triangulation. There's a lot of really fun stuff that could be done. But yeah, any other questions?
If not, I would say we give Caleb another very warm round of applause. And thank you very much for this awesome talk.
Thank you.